Yesterday, you looked at some stuff on Delta Math that talked about increasing and decreasing functions while looking at the graph. So the next step is, can we do the same thing without the graph? Right? So that's our ultimate goal, is to be able to see where a function is increasing or decreasing, but without actually seeing the graph. And that's where a lot of the work with the derivatives will come into play. All right. So for your homework, though, of course, this stuff was created a long time ago, before Desmos or even graphing calculators were available. So these techniques are kind of made for that type of student. But now, of course, we have those tools. So I highly recommend, like I recommended in the past, having Desmos out while you're doing your homework and seeing how your work matches to the graph, so it makes sense what you're doing. Above all else, you want to make sense of what your answers actually mean, right? And not just get answers and say, well, I think I did it right. So check it out, and I'll kind of show you how to do that today. All right, so first off, we know that if going down here, it says if a function is increasing, right, that means the y or the f of x is increasing as the x increases. So both are going up. And then if a function is decreasing, it means the y values are decreasing as x increases. So as you move from, we want to think of this part as x increases. That just means as you move on the graph from left to right, either the graph is going up or the graph is going down. But increases just means you're moving from left to right. And then we looked at that in terms of the derivative, right? So this is the important part here for what we're doing today, right? It says, if f prime of x is greater than 0, then f of x is increasing on an interval a, b. So let's break that down, and what does that mean? So what does f prime of x actually mean? What does that stand for? It stands for derivative, which is the same as slope, right? So every time you see f prime of x, you always want to think about slope. Right? Or even slope of the tangent lines, right? And what does greater than 0 mean? It's another word for that. What numbers are greater than 0? Positives, right? So this is a new language, but there are words that you already know that makes the same sense of what they're trying to say. So this is just saying, hey, if the slopes are positive, the function's increasing. Well, yeah, you probably knew that when you first started graphing. If you have a positive slope is positive, yeah, that means the graph is increasing. From left to right, it's going up. That's all this is saying. All this stuff is saying, and it says A to B, that just means from this point to this point. Right? So it's saying something very common sense. But you still have to understand what these mean. So when you get to the higher stuff, you're used to decoding it and understanding what it means. And after a while, you won't be thinking slope. You'll say f prime of x, and you'll just have this new understanding of what it is. And of course, the same thing is true over here. If f prime of x, right here, if f prime of x, so if the slope of tangents, or however you want to say that, are less than 0, right? If the slopes are negative, right? That means the function is decreasing. And it could be any type of graph. Like this one I can graph. I'll just do something like this. Right? And this time I'll write, this is A, right? This is A and this is B. Right? So if the slopes are negative, that means it's decreasing. Right? That's all it's saying. All right, so we're going to start looking at the derivatives to find out if something is increasing or decreasing. Right? That's going to be our goal. So first, let's just do a little warm-up here and find the derivative and evaluate it at the value they give us. Find out what the slope is, or the speed, or the rate, or the velocity, whatever you want to call it, at that certain value. Okay, so start off with this. Just do f prime of x equals, do the power rule. So we have 2x plus 6. And then use the value that they give us to evaluate at. X equals 5, negative 5. And simplify. So we got -10 plus 6, which is just -4. So the only thing new here is to ask yourself, is this increasing or decreasing? Right? Because it doesn't say what is the derivative at -5. It says, is it increasing or decreasing? So would this number be increasing or decreasing? Decreasing. So you're really just looking at the sign. So because it's a negative, it is decreasing. Right? So this could be a -4, -44, -444. It's all the same answer because it's negative. The number in this sense is really not what we're paying attention to. So pretty much this whole problem is review, except for this last step where you have to declare, is it increasing or decreasing? Okay. If it happened to come out to 0, then it would be neither. All right. So go ahead and do number 1 over here. Oh, I will point out this notation is important. There's a few people that lost points almost regularly. So if you're doing all the number stuff and you're leaving this off, you lost points on your quiz. Some people thought this was like an option, or, well, I don't really need that to get the number answer, so they just leave that part off. That's not optional. It's kind of like capitalizing your sentence. So you cannot just go like this and say, oh, f of x equals x squared plus 6x minus 6, and then say equals 2x plus 6. That's like saying f of x equals 2x plus 6, which it does not. So you have to have that part in there. And when you plug in -5, you need to have this over here, so it's very clear that that's where -4 came from. So if anything else, make sure you have, like always in everything that we did in this class, everything you see, do that. Not some version that's slower or less, don't write quite as much. Everything. All right, so that way when you guys start taking AP tests, you actually get full credit for everything and not get dinged. It's kind of like choosing not to capitalize sentences or spell things correctly and then arguing, well, you kind of get what I'm trying to say. Yeah, but the rest of the world capitalizes and uses correct spelling, so get on board. Stop making rules for yourself. Okay, so next. So like on something like this, it might be a good idea to say equals, because we'd rewrite this as 2 minus x to the -1, right? Because these two are equal to each other. F of x does equal this, and it does equal this. It's just rewritten. So then below that, it makes sense to write f prime and then do the power rule. So we have the negative times the -1 that we brought down, x to the -1 minus 1. Positive x to the -2, which is the same as 1 over x squared. And then finally, from here, we can say f prime of 4 equals 1 over 4 squared equals 1/16, which 1/16 is not important, the fact that it's positive 1/16. Therefore, increasing. Good. All right, so pretty new. Just got to say, it's pre-review. Just new saying increasing, decreasing, and then for some, working on your notation on the left side and writing things correctly, so that anybody else reading your work understands what it is and how you got your answer and what it is you did to get that answer. So now let's take it up a notch. All right, these are kind of some basic functions. Let's look at something a little more fun. So we're going to do the same thing, but for a function like this. Okay? And I'm going to take the time to actually look at this graphically. And so we see as we're solving what it is we're actually doing. So graph this, x to the 4th, no, 4x to the 4th, no, x to the 4th, that's right. X to the 4th, which by itself kind of looks like a wider parabola, but when you start putting on more stuff after it, a 4th degree polynomial usually looks like a w. All right, so I just want to think of it like a fourth degree polynomial of this shape. Yep. And I'm going to kind of change this scale here so I get more of the graph. -5, +5. All right, so it looks like that. And our goal, by the end of it, we're just going to describe where this graph is decreasing. So you can see here, based upon yesterday, it's decreasing when you get to -3. Anything to the left of -3 or less than -3, this is decreasing. You always want to think about from left to right, because if I do this, you're like, oh, it's increasing, it's going up. But you always want to think about it from left to right. So this is decreasing, and then increasing, and then decreasing, and then increasing. So there's two places where it's decreasing. Right here, left of -3, and then from 0 to +3. And we're always talking about the x values here. Right? So thinking from left of -3 and then 0 to +3. Those are decreasing. And then right here, from -3 to 0, it's increasing. Right? This is going up. And from +3 to the right, anything greater than +3 is increasing. So the question is, how do we get that answer? That's the final answer to the question. How do we get that without having this graph in the first place or knowing what it does? Especially if you threw in a lot of other things, if we have like other x cubes, right, and they start bending and twisting in different ways. You know, if this was like a 2 or whatever, or a 22, like how are we going to find out where this is increasing and decreasing, but not having the graph at all? So, as you know from yesterday, if we look at its derivative, right, I'll call this new function g of x equals the derivative of f of x. Right here, this will show us right at -3. You can see this is all negative, right? This is all negative, and it hits -3. Right? So this is all decreasing because they're all negative slopes. And as soon as you hit +3, right, that's where the graph starts becoming increasing. You notice this is all positive, right? So all I need to do is find out where the derivative is positive and negative, and that tells me where it's increasing and decreasing. Right? So this is all negative right here, right? It's negative decreasing right here. And its derivative is all below the x-axis, less than 0. F of x, or f prime of x, is less than 0. And then once again, I hit where it starts increasing again, and that's the same point where it goes from positive to negative to positive, and it starts becoming positive again. So we're really going to look at this graph and find out where is it positive and where is it negative, right? So this is positive above the x-axis, and this is positive. And that gives us the answers we're looking for. This is below or less than 0, and so is this. So these values right here are going to be crucial. So we're going to just find these three values and look between them and to the left and right to see if they're positive or negative, right? These are all going to give us a value of 0, right? And then we'll find other numbers to figure out if it's positive or negative. So that's what's happening here. So first thing we have to do is find the derivative and find out where it is equal to 0. So where does it equal 0? Where do these intersect? And we should get these three answers. Okay? And here we go. So let's first find the derivative, find the rate of change. (4x to the third minus 36x). Find out where this crosses the x-axis, where y equals 0 or f of x prime equals 0. So we're going to set this equal to 0. And then solve. So any given equation will use some different rules for solving. Right? So this, maybe you can do factoring, maybe you could do whatever factoring which works here. But on a different problem, this is a quadratic, maybe you have to use quadratic formula. If it's a fourth degree polynomial, maybe you have to do synthetic division to find out all 4 roots. Right? So this step right here will change depending on what type of equation you have here. And later on, these are going to be like cosine theta, tangent theta, right? And you would have to solve, like that whole chapter we did on solving trigonometric equations, you would have to use all those rules and use the unit circle, right? So right now we're just doing polynomials, but future calculus problems, this could be any type of equation. It could have logarithms, it could have trigonometry, it could have exponents, it could have anything you've seen in the past. So at this point you have to pull deep and find out what you remember about how to solve all those different types of equations, right? So if you're solving this, what do you think the first step should be? Factor what? 4x. So do that. Factor out of 4x. So we got 4x, and we have x squared minus 9. And then what's next? And this one, you'll find out that this part, the algebra 1, this is algebra 1 by the way, that might be the hard part and not the calculus, but remembering how to do this stuff from previous classes. So this is a difference of squares. This is x squared minus 3 squared, right? 9 is 3 squared. So that factors to x plus 3 and x minus 3, right? And this is how we come to find these three roots. So we got our negative 3, our positive 3, and then from the 4x we get the 0. And that's why it's important to be graphing as you're doing the problem. So when you solve this and get your answers, you can actually see those graphically and why they are correct or not correct. I'll let you know if your algebra might be right or wrong, because you know what answers to expect. Now, it's important that these equal 0, right? If this was any other number, we couldn't solve this. So we're using the zero product property. So if three numbers multiplied equals 0, that means one or all of them have to be equal to 0. So that means the 4x has to equal 0, the x plus 3 equals 0, and the x, one of these should be minus. X minus 3 should be 0. There we go. So here, of course, we get x equals 0 by dividing by 4. Subtract 3 on both sides, and add 3 on both sides. That gives us our 3 roots. Okay. So what I'm going to do now is take those 3 roots, and I'm going to graph this part, the green line, where it equals 0, and I'm going to graph these 3 points. I'm just going to put a dot for each of my 3 roots, or if this is a different equation, there might just be 2, right? Or 1 or 4. It could be however many roots are possible. You'd plot all of them. And then you're going to look at the numbers in between to find out, does that give you a positive or negative? So I can pick any number in between these 2 roots. It's going to give me a positive or a negative no matter what one I pick, right? The number's not important, it's the sign. And I'm going to do that for between these two, and then I have to look at to the right side and the left side. Okay, so here we go. So I'm going to go over here to the side, draw a line, like so, and I have my 3 roots. In this problem, there's 3, negative 3, 0, and positive 3. And now I need to test some number between all of them. So what number, let's say, what number less than negative 3 do you want to use? Any number less than negative 3. So we could do negative 4. Right? And then use your calculator to find out what f prime of negative 4 is. Or if the function is simple enough, you might just be able to substitute right in here. But it's a good idea at this point to use our calculator. So I'd say 4 negative 4 to the 3rd power minus 36 times negative 4 type it in that way, hit enter, and we get negative 112. All right, so the fact that it's negative. And then you could check with your graph, and sure enough, yeah, these are all right, negative slopes. If you want to look at the original functions, right, this is decreasing, decreasing. Everything less than negative 3 is decreasing, right, and that's why these are all negative, right. Remember these numbers on the blue, the y-coordinate, that's the slope. That stands for the slope. So right here, right at this point, the slope of the red line is negative 62. Like negative 62 over 1, down 62 over 1. That's the slope of the tangent line on the red line. So that's what all these y-coordinates mean on the blue. It's the slope of the red line at that point. Okay, so definitely decreasing. And we go over here and just repeat the process. So what number do you want to check in between negative 3 and 0? Negative 1. All right, so a good little tool on your calculator here is that you can go back up if you have one of these types. Scroll back up and hit enter, and then you can go back and just change it to negative 1s. Save some time. That gives us positive 32. As we expect, as soon as we hit 3, these are all positive slopes, and that's why down here it's increasing. All that's increasing from negative 3 to 0. And we checked what, negative 1? Right there. So technically at negative 1, yeah, the slope is, let's see here, I can get it, 32. Right, so right at this this point right here, it has a tangent line with a slope of 32. And just keep going through the process. So pick any number between 0 and 3. Let's say f prime of 2. And go back here. F prime of 2. We get negative 40. And pick any number bigger than 3. And we get 4. So try 4. Go do that again for, and we get positive, which do line up with what the graph tells us it should be. So you can see, if we didn't have the graph at all and we weren't checking back and forth, we'd still have the correct intervals of where it's increasing and decreasing. So this part is just a nice thing to have, but we now can do this whole process without even having a graph. Right? Because these are the positive, right here and here, they're above the x-axis. That's where f prime of x is greater than 0. So we have to do one more step and actually answer the question, right? Because it says, where is it increasing and decreasing? So we actually better say that. It's decreasing here, it's increasing there. So we can start off with, where is it decreasing? Just write out the word decreasing and write out the word increasing. All right, and the decreasing will be the same as, where was it? Negative. So that'd be here and here. So everything that was left of negative 3 or less than negative 3. So x is less than negative 3. And everything between 0 and 3. And you saw yesterday it might have given you, different options in the directions on how to write your answers. So we have this set notation, and then we also have interval notation, which you could choose to do. That's fine. So how do you write x as negative less than negative 3? Well, that's all numbers between negative infinity and negative 3. These mean the same thing. And how can you write that with here? Between 0 and 3, that's just this, from 0 to 3. And we should be using parentheses because at 0, the slope is 0. It's not increasing or decreasing. Same thing at 3. Okay, and lastly, go over to the positive side where it's increasing. So those two, increasing is going to be positive. So we have everything between negative 3 and 0. Or just negative 3 comma 0. And then everything greater than positive 3. Or everything from 3 to infinity. You don't have to write both versions. You can pick one or the other. Set notation or interval notation. And then, of course, for at least the first few, check your answer. Make sure you're doing it right. So you should actually physically see, whatever your answers were, yes, it's decreasing. Everything less than negative 3, that's where the graph is going down. Everything between 0 and positive 3, the graph is going down. Everything from negative 3 to 0, increasing. Everything greater than 3, also increasing. And get used to looking at the derivative and figuring out it gives you the same information. This is all positive, increasing. Right? And this is positive over here above the x-axis, so that's increasing. So you can get the answer by looking at the original function or the derivative function if you know how to read the derivative properly. Everything less than negative 3 is negative, below the x-axis, and everything between 0 and 3 is below the x-axis, therefore decreasing. Right, same answers we got here. Alright, so that's the process. Why don't you go ahead and try the next one on the next page using this. Alright, and having your calculator. Hopefully you have one of these where you can just easily substitute in and out some numbers. Give that a try. I'll leave mine up here so you can see it. There you go.